Hello, my name is Calvin Klatt. I'm the director of the Canadian Geodetic Survey. I'm here today to discuss some positioning services, which of course is my interest, and hopefully I'll be able to link that to the Lidar industry and both today and perhaps some of the things that are coming down the line in the future in terms of positioning, precise global positioning and Lidar industry. So I want to take a moment to thank Go Geomatics for this opportunity. And I'll just note that I'm not an expert in Lidar, so I'll communicate the geodetic aspects that are familiar to me. And I'm hoping to learn a bit about from the attendees how these kind of services contribute to the work, and if there's any suggestions or improvements that could be made. So we're looking for feedback on what we could do better. So oops. So very quickly, I'll talk about some work at Natural Resources Canada, just so we put this in context a bit. I'll talk about the current state of positioning, some of the services that we know are used by clients in this area, and I guess the reference system modernization that's underway. And we'll talk next about a couple of things that are coming, the two new technologies that I think are of interest, and we'll conclude later. So first, I work at Natural Resources Canada. I'm part of the Geodetic Survey, but the department also has the Canada Centre for Mapping and Earth Observation. And within that, there's the Canada Centre for Remote Sensing and the National Mapping Agency. And the National Mapping Agency has an initiative called the National Elevation Data Strategy, which may be even more interesting to you than my discussion about positioning. So I'll quickly cover that material, but I'll just note that it's not my material. So that is the GeoBase National Elevation Data Strategy. GeoBase is a collaboration of a number of agencies, including the federal government of Canada. And that the objective is high resolution elevation data. I'm sure you're familiar with that. And the two technologies that they use are LiDAR and satellite imagery. So in particular, the goal would be to have LiDAR data obtained through southern Canada, the part in green here, and the blue part would likely be primarily satellite imagery, so lower quality data. And this is more or less, to some degree, well, that's the productive forest line, but also represents the areas of economic interest in Canada. And I was provided this map of, I guess the current status of this effort. So there's, LiDAR acquisitions of different kinds. So it's so scattered across the country, very large amounts in Atlantic Canada that we see. So I'll kind of that was just a few moments about the National Elevation Data Strategy. My colleagues in the Canada Centre for Mapping and Earth Observation would know a lot more about that than I, so they can be reached. And this is their website for this work. If there's more information, so we can provide that, and you can always reach out to me if you have questions, and I'll feed you to the right people. So now I'm going to move on to the work of the Geodetic Survey, which is positioning services. So what we call that the Canadian Spatial Reference System, and the part of probably of interest is access to that, getting precise positions. Our services actually are global. So if you're not Canadian, it's not just for Canadians. The services we provide are used around the world, and I'll show maps of that. So that's latitude, longitude, height, and height above sea level, but also gravity. So we have that responsibility as well. And we do not charge for any products or services. So I mentioned this before, the Department of Natural Resources Canada has this federal responsibility for positioning standard services. This work, the spatial reference work, is delivered in partnership with provincial governments and some territorial representatives and a few others. And we call that the Canadian Geodetic Reference System Committee. The Department of Natural Resources also plays a leading role in a federal government initiative called Position, Navigation, and Timing Office. And there's an office and a bureau, so that work is separate from the provincial federal work, and it's more looking at a little more the application areas like transport, et cetera, and interference issues and resilience, et cetera. Canada, just a note about Canada, like we are a country that has largely relied on investments in other countries for PNT services. So we're the only G7 nation that has not contributed to a satellite constellation. The UK is joining us in that, but they're also planning some satellites launches very soon. And also some of the foundational observations Canada has not participated in. So these acronyms SOUP you see here, most of them Canada has minimal contributions. The only one we contribute is in the GNSS networks, and we have quite sparse networks. Overall, I would say that strategy has served Canada well, but there are some known problems. For example, the WAS system is having intermittent failures in large chunks of Canada right now. So we have really done well by strategically, I would say, using other systems as others launch and provide services. But it is not a strategy that lasts forever. Sometimes we may have to reconsider that. So, Natural Resources Canada, the Geodetic Survey, were responsible for reference systems and this Canadian Spatial Reference System, and those reference systems will be undergoing a modernization. And this is in roughly 2025. So the NAT83 reference system that Canadians would be familiar with will be changing to the NATREF system, NATREF 2022, and that will be done in conjunction with the United States. So we'll continue, we've had for 100 years or more than 100 years consistent frames across the two countries, and that would continue. And also Mexico is part of this effort. We're also looking to have a new realization of our existing vertical data. This is the CGVD 2013. So the modernization in Canada will be just a new version of that. In the United States, it will be moving to a geoid model, and a major change for them. So in Canada, we have this different reference system, different versions of the reference system in different provinces. So we are looking at this modernization as an opportunity to try to address those inconsistencies between provinces. So we would like to move everyone to more or less the same realization, and in particular the same epoch of the reference frame. So right now there's a lot of because the reference, the North American plate is deforming. There's a velocity model so that represents those changes. And not the overall plate motion, which is absorbed in the system. There should be none of that, but the deformation and some errors in the realization, the definition of this are computed as an epoch transformation. But when you're changing epochs over a period of 25 years, which we are having to do in some provinces, it introduces a lot of uncertainty. So we really want to have the official reference frame in each province to be 2025 or 2022, and have consistency across the board, and no significant epoch transformations for any new data being collected. And so just a bit about that consistency. The United States and Canada are moving together. The United States will go through sort of what we believe, this is a Canadian version of the systems, but we think that in Canada we've done a number of smaller steps and leading towards a 2025 change. The United States will have to go through a number of very significant changes, and so that the challenge is much greater for them. For us, it's our vertical datum is already modernized. It's just the NAPRA 2022 is our primary focus. I guess your users of precise positioning, most LiDAR would require that. And this is a map of our continuously operated GNSS networks from the Government of Canada. There is a number of them clustered in British Columbia. This is for earthquake hazards. We also are showing the new Nova Scotia government stations here. There's a mix of quality of stations. Some stations are, high latency. Maybe the data is collected once a month or something. Others are real-time stations. So if you look at the maps, you need to really understand what each one is, what the purpose is, and what the quality of the data is. There is an expansion of the higher quality stations. So real-time, high quality, high reliability stations. We are installing roughly 22 new ones, or we're converting lower quality stations to be of that type. and that should be done in a couple of years from now. It started now. There's only, I think, just 2 so far, but as shown on the map, but there'll be 20 some in a few years. There is also commercial RTK stations and other commercial services. So those are not shown here, but we recognize that that's a very important way for people to obtain positionings today. So and we do try to communicate with the commercial RTK services, and we have a compliance program, voluntary compliance program, to help everyone understand when there's issues with those services. And I note that we also, we were benefiting from all these satellite constellations, but we also benefit from the WAAS augmentation service in Canada from the United States. So about that precise point positioning service, so that we have a service that allows you to upload GNSS files and have it processed for more accuracy, usually 2 orders of magnitude improvement by using precise orbit information. And it's extraordinarily popular. There's over 1.3 million files were processed in 2022. Most of those are from outside Canada because the service works globally. 200,000 of them are from in Canada, and most of them are dual frequency, which indicates that, which is a professional level receiver. Most are 24 hours, which to us generally means that those are geoscientists, but there's a lot of them are surveyors and other applications. Now this is a map of the global usage. So each black dot is a file that's been processed. It's over many years. So we don't like, we are a bit hesitant to show short periods of time and high resolution maps, but over long periods and global maps we do. So this is a map of where files have been processed. So it's really, to some degree, it's a map of global economic activity. And the UN Global General Assembly has recognized the importance of geodesy and the importance of systems to access the global reference frames. So that is our key Canadian contribution to the global stage. Now, some of you may be using the kinematic mode of this service. So that's a mode that allows kinematic traces of movement of your receivers. That mode is only about, I think, 5% of the total number, but I've shown here a map of where those are located, and it does not, map directly certainly to Lidar. So I think it's a whole mix of different applications. Some of them are definitely geoscience in the high north, in United Nations law of the sea, motion, the ships may be moving, etc. But anyway, just those who are using kinematic, that's a sense of the scale of that and the areas covered by the kinematic services. I just mentioned that the last major upgrade to our positioning service was in 2020, October 2020, and it was we added this something called AR, ambiguity resolution, and it did improve the solutions, but primarily it reduced the time required to get a given accuracy. So I think that was a very significant step forward for clients. For geoscientists, less so, because ultimately in a 24-hour file there was very little difference. But for a client trying to be very efficient in the field, this was a very important step. There are some other improvements that we've been looking at, including atmospheric constraints, but those projects are delayed right now. Just a quick note about economic value. So the government of Canada has, I'm moving on to now kind of a bit about the future of this work. So first off, just, how significant is the position, navigation, and timing service industry, and what is, what do we foresee in the future? So, there've been a number of studies done, Ernst & Young and others, and these have indicated that the precise positioning, particular real-time services, would bring benefits in the billions of dollars per year to Canada, and notably that's at the high precision level. There's also was a study done by Industry Canada, or ICED, about the cost of a GNSS failure in Canada, and it's roughly consistent with what we saw in the UK and in the United States, and it's on the order of $1 billion per day. So that's a little less than that, but that kind of ballpark. Now there's this group, GeoBiz, that have looked at the direct economic impact of geospatial technologies, and they're saying that impact is around $2 trillion globally in 2022. But what's really interesting to me is that they're forecasting that would actually double by 2025 and reach around $10 trillion by 2030. So that's a spectacular growth rate. And it's driven, I would say, by a lot of the new technologies that I'm going to discuss in a minute. So GeoBiz also notes that positioning and GNSS is actually the biggest category within geospatial technologies, and it's roughly half. And basically, if we can trust GeoBiz, and I know that there's pretty large error bars on this kind of work, it's a lot of uncertainties, but the expectation from them is that positioning and GNSS, that category, should have a direct economic impact of over $5 trillion by 2030. So this work of positioning and GNSS is a huge economic element and driver for other types of things like Internet of Things, et cetera. So just one of the studies here. This is an Ernst & Young study done for ICED, the department ICED in Canada, and that study notes, over a long period of time, many billions of dollars, primarily at the centimeter level. That's the bottom blue bar there, and at the upper left is submeter and decimeter. So primarily the benefits seen in the future are going to be nearly all at the centimeter level. And they use a very high, there's a high discount rate used in this, so a high interest rate. So most of the benefits are in the first few years and really tails off as you go forward in time. So these are billions of dollars per year in the near future, as those services are introduced. And so what are those services? So there's sort of two technologies that I think are important. One of them is free real-time PPP services. So I talked about the Canadian PPP service, which is a post-processing service. You mail files in, they get processed. And the world today is all about real-time streaming of information and real-time positioning for vehicles, et cetera. So the key service I think right now of interest is the Galileo High Accuracy Service. It's now available. It's still kind of in a development stage. I think that the official launch is January 2024, and that's here almost right now. The UK is. I was just in the UK 2 weeks ago, and they're developing a plan to provide satellite-based augmentation that would be provide high resilient PNT services and real-time PPP level service. So we're talking centimeter level, whatever that means exactly. We also know that there are proposals being developed in the United States for similar services. We expect that services will be in China, Japan, Australia, New Zealand, et cetera. So there are going to be a number of these, and the Galileo one is global. So then Canada will be able to have that access to that service. Another technology is the low Earth orbiting LEO satellite missions. These are not repurposed communication satellites. These are specifically designed low Earth orbiting satellites for position navigation and timing purposes for satellite navigation. They are higher power because they're lower, closer. The geometry is better because they're actually moving more rapidly across the sky, and they're capable, in some cases, of independent operations. If the GNSS constellation somehow failed, they're looking to have these services work independently. We know there's a commercial group called Zona Space Systems, I believe, and there's the Galileo. So both of those groups, Zona and Galileo, are launching satellites to be testing this. So it's not that far off in the future. We'll have another kind of signal to look at from LEO. So back to the Galileo, a bit more information about that. So I've kind of quoted it here that's going to be free of charge through this Galileo signal, E6, and it's also over the internet. So it's basically a real-time PPP stream, and you need a receiver or a computer that can interpret that and produce your position information. There are two service levels. There's a global service level that would apply in Canada. And given the Europeans are paying for all of these satellites, they have a slightly better service level 2. And the differences in atmospheric corrections that constrain the solutions and improve convergence time. So that will be definitely more efficient in Europe than in other countries like Canada. One of the key factors here is really about automated vehicles. Those economic studies indicate that transportation is really key to the benefits of precise real-time positioning. And that convergent time is a major factor. So it's a major concern about whether that the level 1 would allow use in many transportation applications. So again, Canada will have access to the Galileo service level 1. There was some effort to look into providing atmospheric corrections and to provide something closer to the European level of service, and that was not successful. So that there's no plans right now to provide any additional services to Canadians, and we will not be providing support. So there's no Canadian element to this whatsoever at this point. And I think that ultimately, this is the Canadian position has been to rely on other services and rely on the private sector. So that is, I think, going to be increasingly important as we move forward. And the LEO systems are going to be a very similar thing. So the commercial ones, I think, are going to be, obviously, will have equal access to other countries. We may have less quality because of the lack of basic geodetic infrastructure for the ionosphere and atmospheric constraints. We simply don't have a lot of the data being collected to feed into these services. So we may not quite have the same, but it would be similar. Public good, however, we may have something like the Galileo HAS, where it's a little bit better in Europe than Canada. But I think ultimately there are going to be better services. They will be more efficient. Canada will have some level of benefit from them, and if there's a very significant penalty for us, I think that the Canadian government will have to reassess and step up and provide more support. But at this point, that's not in the plans. So I guess I'll just conclude here. So I think natural resources kind of plays a leading role in the national elevation data strategy, positioning infrastructure services that are very well received within Canada and internationally. Our international colleagues are very complimentary about our PPP post-processing service. We see, if we can believe GeoBiz, we see this massive growth in the geospatial industry, and driven by, I would say, by a lot of it by these new innovative technologies that are going to provide centimeter level, real-time, high reliability positioning. So far, the government of Canada is taking a pretty hands-off approach, but with the note that we will have access to all of the technologies at some level. And obviously the Canadian strategy in this case may require some reassessment as we move forward. So I think that's all I wanted to say, and I'll just I think there's a few questions that I wanted to just kind of ask you, and you don't have to answer now, but maybe you can answer by email or something. So, but we are definitely interested in whether there are improvements that can be made in our work to support you, and I guess just an international comparison. Is Canada a competitive location to do LiDAR work, or if not, why not? Is there something we can do to make it more competitive? So with that, I will stop, and thank you very much for your time.
Hello, Calvin. Thank you very much for your talk. It was very informative.
Thank you. Pleased to be here.
Good. A couple of questions came up in the chat when you were giving the talk. I think you've somewhat addressed them, but let's go through them. Given the advent of high accuracy services and LEO satellites, has the Government of Canada developed a strategy for the future of positioning, navigation, and timing?
Yes, so that's a good question. I guess I kind of talked about how Canada's not being very active. So there is talk of there is not a federal position navigation timing strategy right now. The Position and Navigation and Timing Board housed at Industry Canada is looking into that. So it's something that they're looking to do. And I think the barrier to that is actually that to do that properly requires very extensive stakeholder engagement. If we look at, the Australia model was they had a center of excellence that brought in industry, academia, government, and it had a long period of building better relationships and better understanding of what was required in the different industries there. And then that fed into a strategy and infrastructure investments. So for ISET, I think that their concern is primarily that right now it's a very big job to do that, but it's certainly something that's on their top of their list really for the future.
Okay, no, thank you. I can appreciate your comment about a big job, coordinating and so forth with these other groups. Another question had come in. I'm not sure if it's from the same person, but other countries have services like the Canadian PPP one. What is the difference between your PPP service and the online positioning service Opus provided by the United States Geodetic Survey?
I think so that's also, it's a question that we get a lot from our clients, and a lot of clients will use Opus and then they will use PPP, and so and they have difficulty interpreting the results because there's some slight differences. On the surface, the interfaces are very similar. You send in a file, you get back corrected results. But generally, those services, like Opus is one, but there are numerous ones around the world that are very similar to that. And they use differential positioning. So they rely on a network nearby, and they tell you, basically, these are the stations we're using to determine your position using a differential solution. And what made PPP kind of unique, and it has been, this was, before I joined the government, this was the Canadian plan. And I think it was driven by our geography, which was a very large land mass. We wanted to provide equal access to all Canadians, including the North. So we went with this technology, the PPP technology, which is we compute improved information about the satellites. So we're computing a lot. We're doing a lot of computations about the satellites, which allows that positioning. So there have been times, I think early on that was less efficient than Opus, for example, or the equivalents of Opus. But I think today it's quite comparable, and now we're seeing the advent of real-time PPP services, all of this development. But we basically, it's behind it. So behind it is a very different technology. And we use basically the global network as your reference rather than any individual station. And it makes us more resilient if there's a problem at a particular station. So they're very different. And if you look at the map of Antarctica, you know that there's very little geodetic infrastructure in Antarctica. And so people use our PPP service because it works there. It works quite well there because we're computing precise information about satellites. So we're able to work there. We're able to work in Canada's high Arctic. So we have a solution that serves all Canadians very well. And Opus, these solutions like that could not do that without a very dense network.
Right. No, your map was quite impressive. The amount of dots everywhere. I mean, I especially I think it was maybe Mongolia or somewhere caught my eye as well, that there looked like to be a very hard break that you knew was some sort of geopolitical issue there.
Yeah, we published a paper in Geomatica a few years ago about the service and kind of some analytics about that. And we looked through very carefully every country to see what, the UN list of countries basically. And we found that only one country did not appear to have ever processed PPP data, and that's from their landmass. They may have traveled outside to do data, but and that country was North Korea. So as far as we know, the only place we've never received a file from, it would be North Korea.
Perhaps just as well. I don't know.
Yes. Yeah, no, we saw some ones right along the border. But they were in South Korea. So the South Koreans might have been taking measurements right on the border, but right on their side of the border.
I've certainly used your PPP service, and it's extremely useful. I have never tried to use it though in the kinematic mode. Could you briefly talk a little bit about what one would expect for positioning accuracy there? And
Ah, I'm not sure if I'm prepared to. I think that I think we have one thing about the Geodetic Survey is we have a client support group, and they're actually very good at answering this kind of questions.
okay,
And they're also, a lot of it will depend on how kinematic you are versus how dynamic you are, and what kind of instruments you're using. So I think, and the other thing we should note is that as director, I'm largely ignorant of these things. So I'm afraid of making a mistake, but I do know that our guys can really help with that. I think that ultimately, it's a PPP positioning, and if it's kinematic, you're basically, you should be expecting similar results to PPP, which is, sort of, you should be able to get, a couple, centimeters
yeah,
of accuracy. But I think it's going to really depend on a lot of factors. There are definitely geophysical, airborne geophysics groups that are actually quite expert on this. They probably know better than us what can be done.
Okay. I know when we fly LiDAR surveys, some people are like, I want it the next day. And you need to explain to them, well, fine, we can process a trajectory now, but it will be better if we wait for the ephemeris to improve and so forth. So a lot of folks don't quite understand that.
We've been really focused on trying to provide the service as quickly as possible. Like, the clients want to go in the field, collect as little data as possible to get what they need. And then they want to be able to process it right away. Like, if someone in the field may want to send it in from, as soon as they arrive in the hotel room and get a response back. So we've been very sensitive to the timeliness of this. And that's been really, our focus has actually been more on timeliness and this kind of the amount of data required to get a position versus the end result in terms of, millimeters, centimeters, because we are a client service, organization.
Right. And I guess, so you've addressed the questions from the crowd. I have simply a minor comment for you with regards to, what could we do to help with the LiDAR industry and so forth. I guess the one thing that I've encountered the odd time is there are some CACS networks, for example, Halifax. To my knowledge, it perhaps is collecting at every second epoch, but what's readily available through the web, I believe, is 15 seconds or something. So it's obviously designed for static surveying and things like that. 1 second epoch data would be very useful to the airborne crowd.
Okay, thanks for that. I'll make a note of that.
Yeah.
And we definitely are interested in getting feedback from clients. So, some people may know about the fact that we have masers, hydrogen maser clocks at some stations. We have a subset of those. We had feedback from one client talking about how important that was to them. So, all of this kind of information is useful for us because, hydrogen maser clocks are very expensive. And, sometimes we wonder, does that make a real impact on the ground for users? So anyway, that kind of information and the nature of the data that's available, any issues with latency or, that's all quite useful for us.
Yes.
Thanks for that.
We need to do a survey in southern Newfoundland, so I really paid attention to that green dot that was a new station put in 2022. So that's pretty well where we need to go, near Port aux Basques, by the looks of it.
Yeah, there's a new one at Port aux Basques. It got blown away by a big storm right after
Fiona took it out, did it?
And I just signed off on some reconnaissance work for the west coast of Newfoundland. So that may not be immediately installed, but there's we're looking around for potentially a site in there. That would be one of our new high quality stations.
Okay, so my hopes went up and they came back down with that news.
Well, we fixed the Port aux Basques. I think this fixed now.
Oh, good.
Yeah, it was put up and then smashed down, and I think it's up and running again now. But it will be definitely, if it's not now, it will be very soon.
Okay, that's great news. To the audience out there, this is kind of your last chance to have any questions for Calvin. Very informative presentation. Very interesting what's happening with Galileo and Leo. This is certainly not my area of expertise. I try to keep abreast of it, but and as well, some of your comments about the modernization and NATRF in 2022 and things like that. So that sounds exciting to be fully integrated throughout the North American free trade kind of environment.
Yeah, we're looking forward to that. Like, if we can, so I guess since the 1920s, we've been the NAD 83, the NAD 27 systems have been consistent.
Yep.
And so we're very, we feel that that's, critical that we be consistent. But our height systems are not consistent. They have a Navity 88 system that's quite distinct from ours. And so there's an opportunity to have all of them fully consistent across the board. And then if we can, the provincial governments all have their own legislation that determines what's adopted in their constituencies. But if we can kind of smooth out those issues, we know that commercial RTK providers, for example, have found that a barrier. Like if you're serving somebody on one side of the border versus another, you have a whole different epoch and a version of the reference system. So we're hoping that we can kind of smooth out all of those issues and provide something that's consistent moving forward to the future.
Very good. Well, Calvin, thank you again for a very informative presentation.